First thing we're going to do is go up here and we're going to right mouse click and copy this link. Once you're in KEIL, what you can do is just say File, Clone, and then paste the link in here. Now we already have a 5B, so I'm going to just make this 5B_KEIL and add project. Now the code that we brought in, which was lab5B_KEIL, has a number of support files for 4-digit display, which we're not using at this point, and the Grove LCD RGB backlight, which we are using, as you can see here, where we have included Grove LCD RGB backlight.h. We've also got a couple of function prototypes here, but we don't have the function definitions yet, which can be added later if we want to generate output going to the screen. Initially, we're just going to put stuff on our Grove LCD, as we'll see. Now, besides having our Grove LCD backlight, we've also got AnalogIn because we're going to be taking our input from our pot, which is connected to the A1 connector on our Grove shield. And we did this in the previous lab. And we've got a constant integer max equals 20, which we're going to set to our buffer size. And we're going to need our buffer here for a command called sprintf, as we can see down here. We're going to be using sprintf, as we'll see, and we'll figure out how that works by actually using our trace function here to get a better idea of how it works with either text or actual data that we want to put up to our LCD display. So let's start off by just running our code by hitting our debug symbol here. Now initializing the LCD will cause these bars to show up on the first row here. To run our code, all we have to do is hit this button up here, and when we do, we can actually see voltages here and raw readings here. Now the raw reading is the actual value coming from the A to D, and the voltage is going to be multiplied by 3.3 to give us the actual voltage that's coming in. So if I turn the pot here, you can see that our numbers are going to change all the way up to almost 1, which is 0.99, and almost 3.33, and we can turn it to back again down to 0. Now to analyze our program, what we're going to have to do is go up here and pause. And when we pause, we find ourselves somewhere in the hardware abstraction layer, which is all the things that are happening under the hood. We're not really working at the level that we programmed at. So to get back to that level, we're going to go up here and hit the restart button, and we can see our code here that we were working with. Now, of all the analysis tools we've got threads, call stack, and so on, but we don't want to see threads, so we're going to hide those. Call stack we're not going to use at this point, so we're going to hide that. We're going to hide our registers and hide our breakpoints. And this is going to give us the maximum amount of space here to look at the thing that we're interested in most, our variables. Now, first thing we're going to do is step over, and we can see there that it looks like it's done all the code down to here. And this part of the code, if you look at it, is putting all zeros into buffer, but we can see that buffer here has not got all zeros. It's got garbage here, garbage here. There are some zeros, but they're not all zeros. So let's step over again. Notice it's taking it back from here up, and again, we still don't have all of these elements of an array set to 0. So let's step again. And we see at this point they are all set to 0. So this isn't behaving as we would expect. And the reason for that is because these variables here, voltage, voltage1, and I, have not been set to be volatile. We can't set our buffer to be volatile because that's something that doesn't make sense and it will generate errors, but we can set voltage, voltage1, and I to be volatile variables, and then things will work a lot more like we're used to. Now we can't make any changes to our code to change these into volatile at this point. What we have to do is actually stop our code here and go back here and make those changes. This volatile, and I make this volatile, then we should be able to compile it and set up for tracing again and see how this is going to change how things are going to look in our variables as we actually trace through our variables here. So if now we hit our step over, we can see that we're here just in our for loop, which it wouldn't stop at before. It stopped all the way down here. And what we're going to do now, let's trace ahead, and you can see that's going through this loop. So what I'm going to do is I'm going to set a breakpoint here at lcd.clear and run to the breakpoint, and at this point we can see that all of the values here have indeed been set to 0 as we wanted to. Now LCD clear here is what it's going to do next, but notice down here it's got some random numbers here, voltage and voltage1, because we cleared them to be volatile, and these variables are in RAM. It's going to have some random garbage at each of these locations, and that's what we're seeing here. Until we actually take a value and put it in, it's going to keep these random values, because that's what RAM is made up, is random values when you power up. Now let's take a look at stepping through this a little bit more. lcd.locate is when we do lcd locate over here as we do this, and let's go ahead here. Sprintf reading voltages. So we're going to put that in. You can see reading voltage, and you'll also see here that there's a a null here at this line here. And let's go ahead, and if we trace ahead a little bit more, and we see we're going to print the buffer. We haven't done that yet. And we can see here, strangely enough, that it's set our read voltage here 1 to the right. And the reason for that is we've got an extra locate instruction here where we were going to set it to 0, 0 and reset it here, so it's going to be 1 over. So the way the locate works is 1, 0 means 1 over and 0 down. So the first thing is the column, which is 1, and then the actual row. So what we want to do is we'll probably want to change that later, but let's just continue on. And what we're going to see as we go on to the next step here, it's going to change the background to blue, which it's done. Let's try step ahead now, and notice here it's not quite reading these properly. It's jumping around a little bit, but now we can see our voltage is now 0. And if we go ahead here again, and one more, there we go, then we can see that both voltages are 0. And it's going to then format these as %5.3f and 2 spaces and %5.3f. So as we go ahead again, we can see that on our LCD coming up as we trace through this, when we print the buffer, we can see these values printed out in that format here. So that gives us a pretty good idea of how this code is working. Now let's optimize this program a little better than it is, and there's a couple of things we can change here. For instance, if we look here, max 20, we don't need a buffer size of 20. We need to have enough to actually format up stuff on our LCD, and our LCD is only 16 characters, so we normally think to put in 16. But one other thing that we have to worry about here is to make sure that we have a null at the end, and that null at the end is going to take one extra element. And we've got volatile here. This is all great. Now, we did say that we've got 2 locate statements, and we don't really need this one here, so let's delete that one. And let's see what else we need. And the other thing we can do is now we can actually add an extra character here to center this better. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, we'll have exactly that plus our null, which is our 17th character, and that's why we have to set our buffer size here from 20 down to 17. Now let's run this again. We're going to have to go down here and compile it again. And when we do it this time, we're going to see that our reading on our LCD is going to be a little different. So let's do our trace here now. Step ahead. And we can see here that we got 16 values here plus one extra one, or 17th for our null. So let's just step over this. And actually let's run down to this breakpoint here. And we can see here that we've got all of our elements taken care of. What we're going to do here is before our LCD print buffer, we're just going to go here and run down to that point. And we can see here that we've got part of this here. Let's trace over one more line here. And we can see here that we've got reading space space voltage and our null, which is on our 17th element here, or element 16. Now if we run this and take a look at our screen now, we can see on our screen that reading is all the way across here. There's 2 spaces, and 5.2f means that we've got 1, 2, 3, 4, 5. It's just enough to fill this in. 1, 2, 3, 4, 5. So that's why when we crank our pot here, we're going to see the values go all the way up to there, because we know they're not going to go over 1 digit before the decimal place. And that's a pretty good idea of how our program works.